In this video, we're going to discuss finding arc measures. We'll define what an arc is and define how you measure how big an arc is, in addition to solving some problems involving these angle measures. These 8 terms are terms that we have the written definition in words in the Online Learning Notes 10.2 key file that it's on Canvas, and I highly recommend you pull that up and fill in what these what the definitions are for these terms. I'm going to try to draw up some pictures of these to accompany those written definitions. I think a central angle is an angle whose vertex is in the center of a circle. So if I have a circle, well, that is not a circle. How about something that's more circle and less like potato shaped? And that is also not a circle, but close enough. A central angle is an angle whose vertex is right in the center of a circle. So if this is circle, say if this is circle P, and this is point P, then we'll make an angle by making this like the vertex of the corner of the angle. So, for example, maybe this is angle P would be a central angle because its vertex is right in the center. We say that an arc is a part of a circle that's what's called intercepted by a central angle. So in this picture, or in a picture that's, I'll try to draw a similar one. If we have a central angle, if this central angle is intercepting or hitting the circle, we say that this minor arc is a part of the arc that is a part of the circle that is in between these two. It's in between here. So like this chunk of the circle, oh boy, it's deleting what I want. This chunk of the circle, we say is the minor arc, this part that I try to overlap. A minor arc is always less than 180 degrees, and we label it with 2 letters. So we'll name the points. So if this is say like point A, and this is point B, then we label this as minor arc, or just arc AB, like this, AB, with an arc symbol over top of it, just an arc. A major arc is what's left over when you make a minor arc. So if I have a circle, again I draw a central angle, and I had, say, we'll say this is point C, this point here is point D. Minor arc CD would go from C to D, included in here. The major arc that made by points C and D would be the rest of this circle. And we always label major arcs are always greater than 180 degrees. They're always more than half a circle. And also we label them with 3 letters. So usually we'll say the notation will be a point, and then we're going to walk around a circle toward a second point. So we're going to actually need a third point in the circle. So how about like E? Toward E and end at D. So if I want this major arc that starts at C with an ends at D, I would call this major arc C, go to E, and end at D. So 3 letters for a major arc, only 2 for a minor. A semicircle is exactly half a circle. And you may have guessed it, a semicircle, to make half a circle, then this arc has to be 180 degrees. This has to be made by a diameter. And again, the semicircle is this half of a circle. To measure an arc, we say the measure, or we measure arcs using degrees. And the measure of an arc, or of a minor arc, is the measure of the central angle that is intercepting or making this. It's the measure of the central angle. That intercepts this arc. The measure of a major arc is find its minor arc and then do 360 minus. 360 minus the minor arc. Lastly, we say two circles are congruent if they have the same radii, the same radius. And we say two arcs are congruent if they're made from either, if they have, the arcs have to have the same measure and the circles have to have the same size. So either from the two arcs, they're the same degree measure in the same circle, or two arcs that are the same degree measure and in circles that are the same size. Okay. Again, you can find all these definitions on the filled-in key document that's on Canvas as well. Let's work through a few examples, and then we'll be done for this video. Let's see. Find the measure of each arc in circle C, where AB is the diameter. This is called circle C. This means that the center is C. We'll find the measure, and we'll identify them as major, minor, or a semicircle. So arc AD, that's arc that starts at A and ends at D. This is a minor arc because it's less than half a circle, and also its degree measure is equal to the central angle that's making it up, which is angle ACD, which is 65 degrees. DB is also a minor arc. It's less than half a circle. What's its size? Well, it's the size of this angle. And this angle, well, ACB is a straight line, so the whole thing is 180. This piece is 65. That means that this angle is 115. So arc DB is also 115 degrees. ADB is made by a diameter. It is 180 degrees, and it's exactly half a circle. ABD starts at A, heads toward angle B, and ends at angle D. So ADB starts at A, heads towards B, and ends at angle D. This is a major arc. And what's its degree measure? Well, the minor arc that's associated with it is this little arc AD. If I had gone the most direct way from A to D, I'd have this minor arc, which is 65 degrees. The major arc, what's left over is, well, the 360 minus this small arc that I've taken out. So 360 minus 65 is 295 degrees. Here's a circle. Here's a pie graph, pie chart. Let's find let's find some arc measures here. This should not take us very long. ABC. Start at A, go to B, end at C. 120 plus 82 is 202 degrees. Measure ACB. Start at A, go to C, and end at B. Note that I'm not going to overlap. I wouldn't go A to C and then come back to B in ACB. I'm going to take the most direct route I can to hit each of these three in a row. So A, then C, then B. This would be ACB. I think I could add up each of these three pieces, or maybe I'll try to a little bit different approach in that I'll do 360 take away what's not included. So 360 minus 120 happens to be 240. BD, start at B, end at D. 82 plus 13 is 95 degrees. And then start at C, go to B, and end at D. Start at C, head toward B, and end at D. is 360 minus this 13 degrees, which is 347 degrees. Okay, lastly, we'll identify some congruent circles. We have to state whether these two arcs are congruent or not, and explain why or why not. GF and HE have the same center angle, so they have the same degree measure, but they are not congruent because they are not made from circles that are the same size, or from congruent circles. Is PQ and RS, are they congruent? They are from the same size circle, unlike the previous example. Are they the same degree measure? Well, let's quickly calculate what this central angle here should be. 180 take away 50, take away 65. 180 take away 115 is also 65. They have circle of this. They have arcs of the same degree measure and from the same size circle. I think yes, they are congruent. Is JK and MN, are they congruent? They have the same interior angle, maybe 90 degrees, or the same central angle, 90 degrees. This whole diameter is 12, which means each of these are 6. I think yes, these are congruent.